So good day everyone, I'm April Lambino and I will be discussing about our lesson in physics, which is applying gravitational potential energy. So first, what is gravitational potential energy? So it is the stored energy an object has because of its height or position within a gravitational field. It is the potential of an object to fall. So if you release the object, gravity will pull it down, converting that stored potential energy into kinetic energy or energy of motion. So when we say gravitational potential energy or GPE, the object must be at rest. And the higher the position of an object, the higher its GPE also. So if that object will fall due to gravity, so eventually the potential energy will be converted into kinetic energy or the energy of motion. So when that object is moving, it means that it's releasing energy, which is the kinetic energy. So we have an example here first for the gravitational potential energy near Earth's surface. Calculate the gravitational potential energy of a 2 kilogram book being lifted 1.5 from a table to a shelf. So we have here the given values: 2 kilogram for the mass, 9.8 meter per second squared for the acceleration, and 1.5 meters for the height. So our mass must always be in kilogram and our height must always be in meters. So note that the tabletop is our reference point. So in getting or solving for the GPE, so we have here the formula mass times gravity times height. So we will just substitute all our given values. So 2 kilograms for our mass, 9.8 meter per seconds for our gravity, and 1.5 for our height. So we have the answer 29.4 joules. So that is the GPE or the gravitational potential energy of the book in a height of 1.5 meters. So we have here the second example. So a 2 kilogram book is on a table that is 0.75 meters off the ground. So you then lift the book to a shelf that is 1.5 meters above the table. So we have to solve for the change in potential energy. So in getting the change in potential energy, we have the delta gravitational potential energy. So it is equal to the final GPE minus the initial GPE. So our given values is we have the mass of the book, which is 2 kilograms, the acceleration due to gravity 9.8, our initial height of the book is 0.75, and our change in height during the lift is 1.5 meters. So first we must get the initial. So we have 2 times 9.8 times 0.75, which is the initial height of the book. So we have 14.7 joules. So that's our initial GPE. Then we proceed to the final. We have here 2 times 9.8 times 0.75, which is the initial height, plus the change in height during the lift, which is 1.5 meters. So we must add the two heights because for us to be able to get the final height. Then we will multiply them all and we have an answer of 44.1 joules. So in getting the change in potential energy, we have the delta. So final minus initial. So we have here 44.1 joules minus 14.7 joules. So we have an answer of 29.4. So as you have observed, we have the same answer to the first example. Okay, why? Because both final height of the object are the same. Okay, so now we're going to proceed to our next type of GPE. So this is the general gravitational potential energy formula. So this is different from the past two examples because this is required if the object is outside the Earth's surface or very far from Earth. So we will use this to solve the GPE of objects like planets, satellites, moon, or stars. So our problem is calculate the gravitational potential energy of the Earth and Sun system. So Earth is 5.97 times 10 raised to 24 kilogram. So Sun is 1.99 times 10 raised to 30 kilogram. And our average distance between them is 1.50 times 10 raised to the power of 11 meters. So for the gravity, now we will not use 9.8 meter per second squared because that is the gravity inside the Earth. So now that we're talking outside the Earth, we're going to use the universal gravitational constant. So its value is 6.67 times 10 raised to the power of negative 11 Newton times meter squared over kilogram squared. So our mass of the sun and our mass of the Earth. So our average distance also, which is 1.50 times 10 raised to 11 meters. So in solving for the GPE, in this type of GPE, we have a new formula, which is GPE is equal to negative gravity times mass times the first mass, and also times the second mass over r, or what we call the distance. So r, because it includes the radius of the two objects. So from the center of the Earth to the center of the sun, so that is the distance. Now we are going to substitute the values. So for our gravity, we will use the gravitational constant, which is 6.67 times 10 raised to the power of negative 11 multiplied to the mass of the sun and mass of the Earth over the average distance between each centers. So we have the answer negative 5.29 times 10 raised to the power of 33 joules. Okay, so far that's all for the examples. So we will just be having a short recap. So first question, what do you call the stored energy of an object? Of course, the answer for that is potential energy. So next question, what factors are needed to solve for the potential energy? So we have mass, height, and gravity. Third question, what is the formula for potential energy near Earth's surface? Of course, we have the formula mass times gravity times height. And lastly, what is the formula for the general gravitational potential energy? So we have negative gravity times mass 1 times mass 2 over r. And that's all for today. Thank you for listening.